Radiation in you. Did you know that radiation is simply energy in motion and is all around us, all the time? In fact, you emit more radiation than your cell phone. You must be wondering, what about the radiation that gave our favorite superheroes their powers? Sadly, there are no superheroes in this video. That's for the comic books. Our mission here at the U.S. Department of Energy Office of Legacy Management is to ensure protection of human health and the environment at sites that once played a role in our nation's nuclear defense. This mission includes the management and control of radioactive material, which is why we're diving into the science of radiation. Radiation is all around us, all the time, from both natural and human-made sources. Most of the radiation you are exposed to daily is not harmful because it is non-ionizing. Non-ionizing radiation, as seen on the electromagnetic spectrum, includes radio waves, microwaves, infrared light, visible light, and ultraviolet light. Ionizing radiation, on the other hand, includes X-rays and gamma rays. We use ionizing radiation to heal us when we're sick, explore space, and power the lights in our homes through electricity produced by nuclear power plants. To better understand radiation, let's start with atoms. Atoms are like the building blocks of the universe because they form the basis of all things that surround us, which is called matter. There are three main parts of an atom: protons, neutrons, and electrons. These are characterized by their electrical charge. Protons have a positive charge and are found in the nucleus or in the center of the atom. Neutrons are also found in the nucleus, but they are neutral and have no charge. Electrons have a negative charge and orbit the nucleus, sort of like our Earth orbiting around the Sun. The number of protons in an atom's nucleus determines the element, what the matter actually is. For example, the element hydrogen has 1 proton. Oxygen in the air we breathe has 8 protons. Copper, like what is used to coat pennies, has 29 protons. Most atoms are what we call stable because they have the right number, or ratio, of protons to neutrons in the nucleus. However, when the proton-to-neutron ratio is not right in atoms, we call those atoms unstable, or radioactive. Radiation is the release of energy from the unstable nucleus of an atom as it struggles with being out of balance. That energy travels in the form of waves or particles. There are 4 types of ionizing radiation. This high energy is released from an atom as either an alpha particle, beta particle, neutron particle, or gamma ray. Alpha radiation is created when an atom's nucleus releases or ejects 2 protons and 2 neutrons as a single particle. You can visualize alpha radiation like being a big beach ball. This particle is the largest of the 3 radiation particles and only travels an inch or so in the air. It can be stopped by a sheet of paper or plastic. Beta radiation occurs when a neutron, which has no charge, is transformed into a proton and an electron inside the nucleus, and then the electron is released from the atom as a beta particle. You can visualize beta radiation like a ping pong ball. It's fast and small, much smaller than the alpha particle, and it travels a lot further, up to several feet in the air, and can be stopped by a thin sheet of metal or protective clothing. Neutron radiation is mainly created when a uranium or plutonium atom fissions or splits when creating energy for electricity. Let's visualize neutron radiation as a softball, bigger and stronger than a beta ping pong ball. Neutron radiation can travel hundreds of feet in the air, but can be blocked by materials like concrete or water. Gamma radiation is a ray of energy or wave of energy, so not a particle at all like the other forms of radiation. If alpha radiation is like a beach ball, beta a ping pong ball, and neutron a softball, then gamma radiation is not a ball at all. Rather, it's more like a light beam emitted by a flashlight. This high-energy wave requires several inches of lead, concrete, or steel to be stopped. So, you now have a better understanding of what radiation is and how it contributes to our daily lives. Remember, radiation is energy in motion that is all around us, all the time. It also occurs in many different forms and plays a part of the Office of Legacy Management's mission to protect human health and the environment. We hope you enjoyed learning more about the science of radiation. And thanks for watching! Be sure to check out more information and fun activities on our webpage right here on our screen at energy.gov.